Good morning, students. Welcome back to the today's class. In the previous class, we discussed about the exercise 6.3, in which we majorly focused on algebraic identities. 4 identities we had performed and tried to solve some questions also. So in this particular video, we are going to focus on the factorization of algebraic expressions. So let me give you the main idea. Factorization means, like here already an example is mentioned, 12, number 12 is there, and for 12, how can we factorize this 12? This 12 can be factorized as 2 into 6. 2 is a prime number, 6 is composite number, so this 6 again can be written as 2 into 3. So now 2, 2, 3, all these are prime numbers. We cannot, they do not have any other factors. So here this 12 is factorized by using its factors. 12 is factorized here by using its factors, 2 into 2 into 3. So we call it as prime factorization. And you take any such number. If you take 15, you can write it as 3 into 5. 3 and 5 are prime factors, prime numbers. So this is prime factorization. So any number can be written as product of its prime factors. That is nothing but the factorization. In fact, we can call it as prime factorization. Generally, when we are asked to find prime factorization, we do it like this. We divide it with 3. 3 5s are 15. Then again 5 ones are 5. So 15 is equal to 3 into 5. 3 into 5. So this is prime factorization. So this is very easy to do the prime factorization for the numbers. But how do we do it for the algebraic expressions? Algebraic expressions involve variables, right? So how do we do that? So for that we have 3 methods. One is taking common factor. Second one is regrouping terms. Third one is using identities. Using identities means we had learned about 4 identities. In the previous class we discussed about 4 identities. So we will use any one of those 4 identities as per the requirement. So these are the 3 methods to solve or to factorize given expression. So let's discuss in detail. First method is taking a common factor. Let's look at an example rather than the explanation. We'll understand better. Solution is already there. I'm hiding it so that you can look at it afresh. First one, 12aq(b) plus 9a square b. Here it is, 12aq(b) plus 9a square b. How can we factorize this? Since we are discussing the first method, that is taking a common factor method. Common factor means, in the previous lesson we discussed about writing the factors, common factors. So we discussed about writing the factors, right? Now here we have numbers as well as the variables. aq(b) and a square b, they are variables, and 9 and 12 are numbers. So 9 and 12, they both are multiples of 3. They both appear in the table of 3. 3 4s are 12, 3 3s are 9. So in these two terms, there is a common value. There is a multiple which is 3. I mean, there is a factor which is 3. So that can be taken common. And from these two, actually indirectly, how do we write it? We can write it as 3 into 4 a square b plus this 9 can be written as 3 into 3 a square b. Sorry, here it is a cube b. A cube b. Now in these two terms we have 3, a common factor, so that can be taken common. And then after that we have s cube b and a square b. So in both we have b and b here, and then a cube a square. A cube means a into a 3 times. A square means a into a. So in both we have product of 2 a's common. Product of 2 a's common. So ultimately what can we do here? What we can do here? We can write this 12 a cube b में से 3 common लेते हैं. When we take 3 common, so what is left? 4 is left. Not only 3. Okay, let me write first 3. 4 बच जाएगा and then 4 a cube and b plus. From here also 3 is taken common. So what is left? 3 is left inside. A square b. Done. Now again we have a square b here, a square b here. So we write that also outside, a square b. When we write a square b outside, here 4 is left, and out of a cube b, a square is gone and a is left. So a and one b is already taken outside, and 3 is there. A square b is fully taken outside, so there is nothing left. You can write into 1. Then after 3a square b bracket 4a plus 3. So here the given expression is factorized by taking common factor. What was the common factor? 3a square b is taken as a common factor, and 4a plus 3 is the another factor. The given single expression, which is of 2 terms, is now factorized as product of 2 terms. It's just like writing 2 into 3. When we write in the product form, they are 2 factors. But here, in the given expression, they are not factors. They are simply terms. These are the 2 terms. By taking some factors common, we have written the expression in the form of product. So this is how we can factorize the given polynomials by taking the common factor. So this is about the common factor method. If you want, I can explain one more example. But since the examples are already there, you can go through and you can understand easily. Full explanation is given here. A square b square c minus a b square c square. Full explanation. A square means a into a, b square means b into b, c is as it is. Then again a one time, b square b into c square c into c. This is how we can do the we can factorize the terms algebraic expressions by using the taking a common factor. Second method is factorization by regrouping terms. How do we regroup the terms and how can we factorize it? So regrouping means in a given expression, for example, let us take this one, ab minus x plus ax minus b. Out of these 4 terms, we have ab here and b here. A is common in these 2 terms, or b is common in these 2 terms, x is common in these 2 terms. So we can take any 2 terms in which we find at least one variable repeating. So if suppose if we take these 2 terms ab and ax, what do we have? Regrouping means, what is the concept? Regrouping terms. पहले हम regroup करेंगे. I'll write ab first as it is, and then I'll write ax because this is also involving a plus ax plus ax, then minus x minus b, right? So here we have just regrouped the terms. Now in these 2, what is the common value? After regrouping, we will follow the same, that is the common factor method. A is common in these 2, so I'll take a common here. Now it is b plus x. It is b plus x because a from both is taken outside. Now we are left with b and x. Then here x and b, same term we have here. So minus I'm writing outside. Inside it will be x plus b. Because if you multiply it back, minus into x is minus x, you'll get this. And then minus into plus b is minus b, you'll get this. So writing this way is correct. Next, you see here b plus x or x plus b both are same. So here also it is same. X plus b and x plus b, they both are same in these 2. We have x plus b here and we have x plus b here. That means if a value is repeating 2 times, it can be taken common once. So I'll take it as common x plus b bracket. When x plus b is taken common, here a is left. inside the bracket, and from here the entire term is taken. What is left? Usually you would say answer 0, but that's wrong. It is actually what? X plus b if 1. If there is nothing, it is getting multiplied by 1 always. So when this x plus b is taken common, 1 is left. Why so? Because if you multiply it back, instead of writing 1, if you write 0 here, and if you multiply it back, x plus b into a, you will get this term, first term. But x plus b into 0, 0. You won't get this term. So for getting the previous term, you must write it as 1. Right? So this is how we factorize the term by using the method regrouping terms. Factorization of polynomials by regrouping method. Right? So I hope this example is also easy. This example involves the first method. Now, after that, factorization using identities. Since we had already discussed the 4 identities, 1, 3, 2, 4, we have 4 identities. So out of these 4 identities, we will use any one of the 4 as per the need of the question. Now let's look at this example. Factorize the following using suitable algebraic identities. The question is to use the algebraic identities, and the goal of the question is to use to factorize. Goal of the question is to factorize, and the medium we need to use is the algebraic identities. Right. So let's have a close look at this. P square, first one, P square plus 8PQ plus 16Q square. How do we use that? How do we factorize it? P square, let me apply mask here. Yeah, P square plus 8PQ plus 16Q square. If you carefully observe this, it involves the one of the 4 identities. Which identity it looks like? It is like a square plus 2ab plus b square, which is equal to a plus b whole square. Okay, anything you see in this format, that can be written a plus b whole square. So when you write a plus b whole square, that is the factorization, because a plus b whole square means a plus b into a plus b. Square, whole square means product of the same thing for 2 times. Okay, now let us take this one, p square plus, we need to compare this one with the identity. So p square means it's like a square. In place of a, we have p variable. So first term is matching. Second term is 2ab, but in the question it is 8pq. So let us write it as, can we write 2, can we write 8 as 2 into p into 4q? Can we write it this? Because when we write it like this, the value doesn't get changed. 2 into p, 2 into 4 is 8, p into q is pq. So it will be 8pq as it is. We are just reframing it so that it can match with the identity that we want to use. And then 16q square. Can we write 16q square as 4 square and q square? Your answer will be yes, because 16 is equal to 4 square. 4 square means 4 into 4, which is 16. Now see this again. P square plus 2 4q plus, now the square is for both the 4 as well as q, both are having square terms. So now write it as 4q and then whole square. Square is taken common. Now compare it with the given identity. The p square, a square, 2 a. In place of a, we have p, and in place of b, we have, that is 4q, and b यहाँ पर जो हमने लिया है उसी का square यहाँ पर भी आएगा, and this is matching. So all the terms are matching with the pattern of a plus b whole square identity. So what do we do now? We will write it as just like how the way we write plus for a plus b whole square. Here also in place of a we have p, in place of q we have b, we have 4q and whole square. So here now it is factorized, but we need to show it in the product of form of product of two numbers. So we'll write p plus 4q is one factor, and then p plus 4q, the same one, is another factor. If you take number 4, it will have 2 into 2. Factors are same. In the same way, here also the factors are same. P plus 4q into p plus 4q. So this way we can use the a plus b whole square identity for uh, for factorizing the algebraic expressions. Now let us take the second one. Second one is 4x squared minus 24xy plus 9y. Now here the variable is changed, but the format is same. 4x squared. The way the moment you look at the question, you need to observe and identify which identity is can be applied over here. See here, one square term we have, and product of two variables, and then one variable. Okay, so here in this we have just a minute. 4x squared, 2x whole square, x plus a into x plus b, 2x whole square minus 2x into x plus a to 6. This one is looking a little different. I think this must be 9y squared. 2, 4, 3 are 12. Just a minute. Here rather than 24, it should be 12 actually. So here in the explanation of second one, it is 2 to the 4, 4 3 is 12. So the question is given wrong. It is 12. You can modify it in your textbook also. It is plus 9 by, and plus 1 and 9 by is same. Rather than 24, you write it as 12. Okay, now let me apply the mask here. 4x squared. So 4x squared can be written as 2x whole square, then minus 2 into. Well, if you want to use the identity that is a minus b whole square or a plus b whole square identity, you must write it in the same form. So in the expansion of a minus b whole square, there should be minus 2 into a. What should come in the place of a? Whatever you have written here, that should come. So we'll write 2x into. What should come in b place? This 24. Whatever you have taken here, the middle term is 24. That is actually we are expanding. Out of 24, we have written it as 2 into 2, 4. So, sorry, this is actually 12. So, this 12 is written already as 2 into 2, 4. So, 12 को 4 से आप divide करोगे, what is left? 4 3s are 12. So, how much is left? 3 more is left. So, you'll write it as 3 into y. This 24 is being splitted as three terms. One is constant as per the formula 2, and second one is a value, that is whatever you have written in the square format in the first term, that is to be written here, and then third term is the remaining term. When you divide the entire term with already written two terms, whatever the question you get, that you will write here, plus 9y. 9y can be written as 3y. Here again it is square, 9y square, 3y whole square. Therefore, you see that it is a minus 2ab plus b square. So you can write it as 2x a minus b whole square, 2x minus 3y whole square. So usi ko आप 2x minus 3y into 2x minus 3y, product of two terms. Hence it is now factorized by using the identity a minus b whole square. So this is using second identity. Now let's look at the third identity. When we use the third identity, here the question given is of third identity, 81x square, 81x square minus 49y square. Since you already know the tables, the moment you look at these numbers, you will get immediately know 81 is product of 9 nines are 81. So you can write it as 9 square, 9 square x square minus 49 can be written as 7 square y square. So you see that these two terms are having same powers. So you can write it as 9x whole square minus 7y whole square. Okay, so which identity is applied here? A square minus b square identity. A square minus b square is expanded form, and when we write it in the product form, how does it look like? It is a plus b into a minus b. Okay, so here what do we get? What is the answer we get for this? This is to be written in the product of a plus b into a minus b. So in what is there in place of a? We have 9x plus what is there in b? We have 7. So 9x plus 7y is a plus b into what is there in a plus 9x, and what is there minus what is there in b plus? It is 7y. So we have 9x plus 7y into 9x minus 7y. These are the two terms which are written for the expression 81x square minus 49y square. So this is how we can factorize the given polynomial using the identity. So here we have applied the third identity, that is a plus b whole a minus b, a square minus b square is equal to a plus b into a minus b. Now let's look at the fourth one, that is 32a square minus 50. How the explanation is given here? Here the explanation given is 32a square minus 50 is equal to, in both there is 2 common, 2 into 16 is 32, 2 into 25 is 50. So 2 into 16a square minus 15 it's written. After that 2 into this 16 can be written as 4 square a square, 4 square a square minus 25 can be written as 5 square is equal to 2 into, again we have 4 square a square can be written as 4a whole square. The square can be applied for both terms minus 5 square. So inside the bracket we have two terms which are in the form of a square minus b square. That can be written as 4a plus 5, that is a plus b, into 4a minus b, which is the second term. So inside the bracket whatever we have written it as 4a plus 5 into 4a minus b as per the a square minus b square identity. That's what you see here in the brackets. So this is how the fourth question is solved. Actually there is one more example is to be given, which we call the fourth identity, x square plus x into a plus b plus a into b. This example is not given, but you can see in the exercise questions. Factorizing by splitting the middle term. So this is the another method, but as of now, since we have discussed the three methods, factorizations by using common factor method, regrouping terms, and then identities. So we will try to see the questions also based on these three methods. Factorization by splitting method, that we will see in the next class. Otherwise, you will forget everything. So let's look at the questions in the exercise. First question is, find the common factors of the following terms. So here you just need to find the common factors. What are the common factors? Xy and xy. So in these two, xy comma x square y, what are the common factors? X into y is the common factor because x into y is here in this term. X into y is also there in the second term. So that is the common factor. In that way, find out the common factors for all this, question number one. And question number two, find the factors of the following polynomials. Now here, what you are supposed to find? Just the factors. How do you find the factors? 3 into x square yz. So 3 is factor for x square y, I mean for the given one. For 3x square yz, we had discussed in the previous class in the last week. 3 can divide the whole term, so 3 is a factor. X square can also divide the whole term, so x square is a factor. X can also divide, so x is a factor. Y can also divide, y is a factor. Z can also divide, z is a factor. Then 3x square y can divide, so 3x square y is a factor. 3x square z can divide, so like this, whichever the value can divide the given whole term is a factor. That way you can write answers for all these questions. Very simple. Okay, as many as possible you can write the factors. That's question number 2. Then question number 3 is taking the regrouping the like terms. Here you have to regroup the like terms as we discussed in the example. Lm plus mn, il plus an. So you take any two groups, two terms, L, M. So in these two terms you have M common, M bracket, L left inside, and second N left inside. Plus in these two terms you can take common A. So A is taken common, L is left outside, plus N is, I mean inside. So you see that L plus N, L plus 1, they are same. Now write L plus N here common, then we have M plus. So the given 4 terms are now factorized as product of 2 terms. Okay, so this is how we can factorize the given polynomial as we discussed by using regrouping like terms. We can do for the same remaining questions also. Then the fourth question is factorize the following by using identities. The first question can be used solved by a square minus b square identity. I'm telling here the identities. For the second one here you have square term, product of square and constant and variable, and then we have product of, I mean only the constant values. This is the example of fourth identity, x square plus x into a plus b plus a into b. So that's the second identity. For fourth C1 you can use the a minus b whole square identity. I'm giving you the clues. Then for the second D1 use this same identity, a square minus b square. Then for E use the identity which we have used in B. And for last one, it is actually you need to expand it. A minus b whole square, write it as a square minus 2ab minus plus b square, then minus b minus c whole square means b square minus 2bc plus c square. After that, open this bracket. That means we'll get all the 3 terms as it is, minus 2ab plus b square, and then from here minus will be applied. Minus into b square is minus b square, minus into minus plus, it is 2bc then minus into plus c square is minus c square. So here we have minus b square plus b square cancel. What is left? A square minus c square minus 2ab minus 2bc. So here it is minus 2ab plus 2bc. So what is common in both? Here we have a square minus c square minus 2ab into 2bc. So 2b is common. You can take it as 2b into a plus c. So this way you can continue it. But actually here what is asked? Using identities. Okay, we don't require to do all this stuff. A square, this is actually looking like a square minus b square. In place of a we have a minus b, and in place of b we have b minus c. So anything which looks like a square minus b square, it should be written in the form of a plus b into a minus b. So as per that, in place of a we have a minus b. So write a minus b plus in place of b we'll write b minus c. B minus c. This comes in the first bracket. In the second bracket we have a minus c, a minus b. In place of a we have a minus b minus in place of b we have b minus c. But when you open the bracket, this bracket, the minus b will be as it is. Minus c becomes plus c. So I'm writing it directly. Now here minus b plus b is cancelled. Again, here a minus b. A is a plus b. This is plus b minus b cancel. A plus c is left. So here a minus c and a plus c. So this is the product of the given polynomial s minus b whole square minus b minus c whole square. So this way you can solve till question number 4. The other questions, question number 5 and 6, we'll discuss in the tomorrow's class. So I hope you understood these questions. Write all the answers in the notebook, including the examples, and solve the exercise questions. If you have any doubts, you can send me the queries. That's all for today. See you tomorrow. Bye bye.